is thermochemistry, which is a part of thermodynamics only. Okay. So entropy. What is meant by entropy of a system? It represents, okay, so 1, 2, 3, R, D, M. Okay. So R stands for randomness of a system. Okay. So what is meant by randomness? Randomness means what? Randomness means we don't know how atoms and molecules they are arranged. Are you able to understand? They do not have a regular pattern. That type of arrangement is called as randomness. Are you able to understand? D stands for disorderedness. Okay, there is no particular order in the system. Are you able to understand? And M stands for mixing, which is present in the system. For example, if I mix two gases, then it is called as mixing of gases. No? So therefore, entropy represents these values. It represents randomness of a system, how random the molecules and atoms they are arranged, and disorderedness of a system, what is the order which is not present in a system. Are you able to understand? Also it represents mixing of a system. Okay. So how different elements or different metals or different gases they are mixed together. Are you able to understand? So therefore entropy represents these values: randomness, disorderedness, as well as mixing of a system. Now let us try to understand this one by taking an example. Okay. See, for example, if I say take solid, if I take liquid, and if I take gas. Are you able to understand? So in the case of solid, the atoms or molecules they are arranged in a particular fashion. Oka particular fashion lo anni arrange ayi untayi. Are you able to understand? Whereas what about the atoms or molecules in the case of a liquid? They are not arranged in a particular order, no? Because for example, if you take water, the molecules of water they will be continuously in motion. Are you able to understand? Then what about gas? We cannot say anything about gas molecules. Are you able to understand? Therefore, out of them, out of a solid, liquid and a gas, which has more randomness, which has more disorderedness, definitely gas, no? So therefore I say that entropy of a gas must be greater than entropy of liquid. Are you able to understand? And it should be greater than entropy of a solid. So least entropy is present for the case of solid. Because entropy represents what? It represents randomness and disorderedness, and it represents mixing of the system. Are you able to understand? So gases have highest randomness when compared to solid state or when compared to liquid state. Are you able to understand? Okay. Similarly, for example, see here S represents entropy. S represents entropy. Clear? Similarly, if I take one more example, for example, if I convert water into ice. Are you able to understand? I am converting what? I am converting water into ice. Now the entropy of the system, has it increased or decreased? Can you say? System entropy periginda taginda? Decreased. How can you say? How can you say? In the height lona, length lona, breadth lona, dentlo greater. How can you say that entropy of water is greater than entropy of ice? Ela cheptaru? Because the molecules in water they are not arranged in a particular fashion. A particular fashion ikkade untayi avi undavu kada. It means the entropy of water is definitely greater when compared to entropy of ice. All the water molecules in the ice they will be present in a particular spot itself. Are you able to understand? So their randomness is very less. Their disorderedness is also very less. Are you able to understand? So therefore I say that entropy of water is greater than entropy of ice. Are you able to understand? Clear? Then here we discuss about delta S. What is meant by delta S? Delta S means what? Change in entropy. Are you able to understand? Change in entropy. Now can you say how can I calculate a change in entropy in this condition? Ee condition lo change in entropy ela find out chestam? No, change in entropy is always written as final value minus initial value. Change antene final minus initial kada. Whatever may be the change in kinetic energy, change in momentum, change in entropy, change in enthalpy, always you have to write final value minus initial value. Clear, Nama? So therefore I can say, so the entropy of ice minus entropy of water. Are you able to understand? No? So this is the change in entropy of the system. Okay. Now can you say this value, is it a positive quantity or a negative quantity? Negative quantity. Why? Because S of ice is greater than entropy of water, no? This value is lesser, this value is greater. So smaller minus bigger value, negative value or positive value? Negative value. So therefore I can say in this condition, okay, ma? So here delta S, or you can write ds, is negative. Are you able to understand? Clear, no? Are you able to understand why it is negative, ma? Negative represents what? Negative then chupistundi. Negative represents that entropy of the system has reduced. Our system entropy emayipoyindi, taggipoyindani chupistundi. Okay, ma? So therefore negative value of delta S or ds represents what, ma? Represents entropy of system. Entropy of system has reduced. This is what I understand, no? Let us take one more example. See, ma, for example, if I convert water at 100 degrees Celsius to steam at 100 degrees Celsius. Are you able to understand, ma? Water at 100 degrees Celsius I am converting into steam at 100 degrees Celsius. Now entropy of the system, is it positive or negative? Change in entropy, is it positive or negative? Change in entropy, is it positive or negative?
Positive.
Positive. How can you say? How can you say? Entropy of water is definitely less than entropy of steam. Are you able to understand, ma? Because this is in liquid state and this is in gaseous state. So definitely entropy of gas is greater, no? So the disorderness, the randomness of gas is greater when compared to water, when compared to liquid state. Are you able to understand? So therefore here I can say entropy of water is definitely less than entropy of steam. Okay, ma? Therefore what is delta S or ds? Delta S or ds means change in entropy. Change in entropy, how should I calculate, ma? So entropy of steam minus entropy of water. This is how I have to calculate, no? And this value here I will get, it is positive. Okay, ma? And what does positive value indicate? Positive value then chupistundi. Positive value indicates that entropy of the system has increased. This is what we understand. Are you able to understand? So make a note of that point. So therefore what I write? Therefore I write here that, so positive value of delta S or ds represents what, ma? Represents that entropy of system has, chapandi, entropy of system has increased. Okay, ma? This is what I understand. Are you able to understand? Now basic concept of entropy, it is clear, no, ma? So what is meant by entropy? How random a system is present. So what is the amount of disorderness which is present in a system? So how many elements or how many gases or how many liquids they are mixed together, that total measure is called as entropy of a system. Are you able to understand? Now let us study the factors on which entropy depends upon. Factors on which, or we can say some examples of which how we can study the entropy change. Factors on which entropy depends upon. Are you able to understand? So first factor is entropy is directly proportional to atomicity. Okay, ma? Entropy is directly proportional to atomicity. Now can you say what is meant by atomicity? Atomicity means what? Chapandi. Number of molecules, number of atoms in a molecule is called as atomicity. This is called as atomicity, no, ma? For example, we will take example of helium, we will take example of oxygen, and we will take example of ozone. So in this condition, what is the atomicity of helium, ma? 1, because in this total molecule only one atom is present. What is the atomicity of oxygen? 2, because in this molecule 2 atoms are present. What is the atomicity of ozone? 3, no? because in this molecule 3 atoms are present. Are you able to understand, ma? Now out of helium, oxygen and ozone, which is having highest entropy? Ozone is having highest entropy. What is the reason? Because its atomicity is greater. So therefore I write that atomicity of ozone is greater than atomicity of oxygen is greater than atomicity of helium. This is what I can write. Okay, ma? So what is the reason for this one? That also we will write here. So reason why if atomicity increases, entropy also increases. Okay. Reason is that, okay, as atomicity increases, okay, ma, number of bonds will increase, no, ma? Number of bonds will increase. Clear? Bonds are elastic. What is the nature of bonds, ma? Bonds are always elastic. Are you able to understand? So continuously they will be elongating and compressing. Are you able to understand, ma? So if atomicity increases, number of bonds will increase, no? Okay, ma? And what is the nature of bonds? Bonds are always elastic. For example, if you take this oxygen molecule, so there will be a bond between them, no, ma? Are you able to understand? So these bonds continuously they will be vibrating about their mean position. It means that the randomness of the system has increased, no? So as the number of bonds increases, entropy of the system also increases. And number of bonds depends on atomicity. Are you able to understand? So therefore if atomicity increases, entropy also increases. Clear? Okay. So here I will write one case, ma. Case is that if atomicity of elements is equal, then what is the condition? If atomicity, if it is equal, then entropy depends on what? Entropy depends on, okay, ma, molecular weight. Entropy depends on what, ma? It depends on molecular weight. Okay. So in this condition I can write entropy is directly proportional to molecular weight. Okay. So this is satisfied in which condition, ma? This is satisfied only when atomicity of elements if it is equal. Okay. For example, what is the example I can take? Let us take halogen elements. Clear, ma? So fluorine, chlorine, bromine, iodine. So all the atomicity of all of them is how much? Atomicity is 2, no? Then what about the entropy of them? Entropy of fluorine is greater, entropy of chlorine is greater, or entropy of bromine is greater? Bromine. How can you say? Molecular weight of bromine is bigger, no? Molecular weight of chlorine is bigger than fluorine. Okay. So therefore I can say that molecular weight of bromine is the highest. Okay. Therefore what I can say? Therefore I can say entropy of bromine is greater than entropy of chlorine is greater than entropy of fluorine. Are you able to understand? So this is one factor on which entropy of the system depends upon. So what is the first factor, ma? First factor is atomicity. And if atomicity is equal, then I have to check for molecular weight. So the atom which is having highest molecular weight, it will have highest entropy. That's it. Clear, no? Okay. So the next factor which I study is, I will study in the case of a chemical reaction. Okay, ma? In the case of a chemical reaction. Okay. So delta Ng, if it is positive, then, clear, ma? Delta S is also positive. Okay. Delta Ng, if it is negative, delta S is also negative. Okay. So in the case of chemical reaction, we know what is meant by delta Ng, no, ma? The change of number of moles in the case of gaseous condition in a chemical reaction is called as a delta Ng. Okay. So if delta Ng is positive, then delta S is also positive. Delta S is positive means what? Entropy, is it increasing or decreasing? Entropy increases. Clear, Nama? Similarly, for delta Ng, if it is negative, then entropy also will be negative. Are you able to understand? Now let us see one example of what is meant by delta Ng. Ma? So delta Ng, how can I write? See here, I will write down. Delta Ng can be written as, clear? So number of moles, or I can write gaseous moles. Number of gaseous moles of products minus number of gaseous moles of reactants. Okay, ma? This factor is called as delta Ng. Okay. So how many gaseous moles are present in the case of products? Minus of number of gaseous moles of reactants. So this is subtraction if you do, then I will get delta Ng. Are you able to understand? Let us take one example. Ma. Example is 4 moles of A gas plus 5 moles of B gas. They react to give 6 moles of C gas plus 3 moles of D gas. Let us consider this is the equation. Okay. So A and B are what? They are gaseous molecules only, no, and they are reactants. Okay. And C and D, they are what? They are also in gaseous form, but they are the products here. Now what is meant by 4 and what is meant by 5? I can say 4 atoms, or I can say 4 moles also. No? Similarly, 5 is 5 atoms are 5 moles, 6 moles, 3 moles. Are you able to understand? Now according to this relation, can you say how can I calculate a delta Ng? Ma? Delta Ng, how can I calculate? Number of gaseous moles of products. So this is the product, no? So how many number of moles are there totally? 6 plus 3, no? Minus of, what are the number of gaseous moles in the case of reactants? 5 plus 4. 5 plus 4. So totally how much, ma? 6 plus 3 is 9, minus 9 is how much? 0. Okay. So there is no change in the case of delta Ng. Delta Ng is 0. So therefore in this condition I can say that delta S is also 0. There will not be any change in entropy. Are you able to understand? So if delta Ng is 0, I can say delta S is also 0. If delta Ng is positive, delta S is also positive. Delta Ng is negative, then delta S is also negative. Are you able to understand? So delta Ng will become positive in which condition? Delta Ng positive eppudu avutundi cheppandi. Delta Ng will become positive in which condition? When number of moles of products is greater than number of moles of reactants. Then delta Ng will become positive. Okay, ma? It means number of moles are increasing, no? After the chemical reaction, number of moles, what is happening? Number of moles are increasing. If number of moles are increasing, then randomness of the system increases, disorderness of the system also increases. So automatically entropy also increases. That is the reason. Reason you did not remember, just remember this one. Are you able to understand, ma? If delta Ng is positive, delta S is also positive. If it is 0, delta S is also 0. It means there is no change in entropy in this condition. Are you able to understand? This is another factor which you should remember. Okay, ma? The next factor is, okay, third one we will write, entropy of allotropes is greater than entropy of pure metals. Okay, ma? Or you can write entropy of pure elements also. Are you able to understand? See, ma, for the same element, we have many allotropes are possible, no? For the same element, many allotropes will be possible. For example, you should have studied in carbon chemistry, no? Organic chemistry. Carbon has many allotropes. Are you able to understand, ma? So, in the case of allotropes, the entropy automatically increases when compared to original element or original metal. Are you able to understand, ma? This is another factor. Similarly, for example, if I take a boiled egg, okay? If I take an egg and if I boil this egg, entropy will it increase or decrease? ఒక గుడ్డును తీసుకొని ఉడకబెట్టినాం అనుకోండి, ఎంట్రోపీ పెరుగుతుందా తగ్గుతుందా? Decrease. How can you say? But here when you boil egg, entropy increases. This is one exception which you should remember. Okay, ma? If you are boiling egg, what is happening is the complex proteins which are present in the egg, they are split into many simple proteins. ఒక ప్రోటీన్ 10 ప్రోటీన్లుగా స్ప్లిట్ అవుతుంది అన్నమాట. ఇట్ మీన్స్ number of proteins are increasing, no? Number of proteins will increase. Automatically randomness, disorderness of the system will increase. Are you able to understand, ma? So in this condition, what happens when egg is boiled? Okay, ma? Complex proteins break down. Okay, and entropy increases. Entropy of the system increases. This is one point which you should remember. Clear now? Similarly, some more examples can be given in the exam. Rusting of iron. So on iron, rusting will take place now, oxidation process. Okay, so here also what happens, ma? Delta S will be positive. Delta S is positive means what? Entropy of the system increases. Are you able to understand? Similarly, if I take some more examples like crystallization of sugar, all this I think you can understand. So crystallization of sugar solution, or just a crystallization of sugar. Can you say what happens, ma? We have sugar in the form of liquid. Are you able to understand, ma? After some time, it has converted into solid form. So entropy of the system, will it increase or decrease? Decrease. Entropy decreases because it is converting from liquid form to solid form, nama? So solid entropy is definitely lesser. Are you able to understand? So here change in entropy is what? Negative. It means entropy decreases. Liquid form లోంచి solid form లోకి కన్వర్ట్ అయినప్పుడు ఏమవుతుంది? ఎంట్రోపీ తగ్గిపోతుంది కదా. Disorderness of the system reduces. Disorderness or randomness, if it reduces, it means entropy also reduces. Are you able to understand? Just like water converting into ice. Water is in liquid form, no? Ice is in solid form. There entropy reduces. No, here also entropy reduces. That's all. Are you able to understand? Let us take one more example. For example, adsorption of gas. Adsorption of gas. It is not absorption. I am discussing about adsorption. Adsorption means what? Sima, this is a metal surface. So in the atmosphere, many water molecules are present. H2O molecules are present. After some time, all these H2O molecules, they get deposited on the surface of this metal. Okay? Water vapor untundi kada manaku. ఆ వాటర్ వేపర్ అంతా మెటల్ సర్ఫేస్ పైన సెటిల్ అయింది అనుకోండి. ఆర్ ఏబుల్ టు అండర్స్టాండ్? నౌ ఇన్ దిస్ కండిషన్ ఎంట్రోపీ ఆఫ్ దిస్ సిస్టమ్ హ్యాస్ ఇంక్రీస్డ్ ఆర్ డిక్రీస్డ్? Entropy, has it increased or decreased? Decreased. How can you say? Gas to liquid form it has converted, no? When all the water molecules, when they were present in atmosphere, then randomness will be greater. Now when they settle on the surface, now they are converted into liquid form, no? చూసింటారు కదా మీరు, కూల్ డ్రింక్ బాటిల్ చల్లగా ఉండేది టేబుల్ పైన పెడితే మొత్తము వాటర్ అంతా వచ్చి దానిపైన సెటిల్ అవుతుంది. మన జయంతి ఏమనుకుంటుందంటే లోపల ఉండే కూల్ డ్రింకే బయటకు వచ్చింది అనుకుంటుంది అనమాట. యాక్చువల్లీ దట్ ఈస్ నాట్ హ్యాపెనింగ్. ద వాటర్ మాలిక్యూల్స్ విచ్ ఆర్ ప్రెసెంట్ ఇన్ ద అట్మాస్ఫియర్, దే గో అండ్ సెటిల్ ఆన్ ద surface of the water bottle. Are you able to understand, no? So this process is called what? Adsorption. So previously gas molecules, they were in gaseous form. Now they have converted into liquid form. Are you able to understand, no? So therefore in this condition what happens to delta S? Delta S is negative. It means entropy of the system has reduced. Are you able to understand? So like these of examples can be given in the examination. Okay, you have to identify whether randomness, disorderedness, mixing of the system, has it increased or decreased. Based on that you can answer any type of question. Are you able to understand? That's it. Make a note up to here. Okay, now let us write the equation of entropy. What is the basic equation of entropy? We will try to understand. Completed up to here? Okay, now see. See ma, listen very carefully. Equation of entropy. See ma, this is a system. Okay ma. In this system, some gas is present. Okay, and let the temperature of this one is T1. Okay ma, and this is the surroundings. Okay, so this is the system and this is the surroundings. System plus surroundings is called what? Universe. System plus surroundings, you can call it as universe. Are you able to understand ma? And the temperature of the surroundings is T2. So if T2 is greater than T1 and walls are diathermic, then can you say what will happen? Okay ma? Temperature of the surroundings is greater than temperature of the system. And what are the walls of the system made up of? Walls of the system are diathermic walls. What is meant by diathermic walls ma? Change in temperature, inka correct?
Don't exchange.
No?
Exchange.
Exchange of heat energy, temperature. Exchange of heat energy can happen. Such type of walls, they are called as diathermic walls. Opposite of diathermic walls? Adiabatic walls. Adiabatic walls cannot exchange heat energy. So diathermic walls means they can transfer heat energy from the system to the surroundings and from surroundings to system. Are you able to understand now? Now in this condition what happens? Heat energy flows from where to where? From surroundings to system. This is what will happen now. When walls are diathermic, heat energy enters from surroundings into the system. Okay. So let Q amount of energy has entered. Enta energy enter in the from the surroundings to the system, Q amount of energy has entered. Are you able to understand? Therefore, in this condition, okay ma? So are you able to understand what is happening? So T2 is the temperature of the surroundings, T1 is the temperature of the system. T2 is greater than T1, then heat energy enters from surroundings to the system. Are you able to understand? Then ds, change in ds means what? Change in entropy of the system. Which is the system here? This one is called the system. No? So change in entropy of the system is how much ma? Amount of heat energy received by the system. In which process? In reversible process, divided by time, divided by temperature. Are you able to understand ma? See ma, what is meant by reversible process and irreversible process already we have studied no? In the reversible process, pressure is not a constant, pressure is a variable. Are you able to understand? That is called as a reversible process. And this equation is satisfied only in the case of reversible process. In irreversible process, this is not satisfied. Are you able to understand ma? So make a note of that point. Note is that above equation is satisfied only in which process? Only in reversible process. Are you able to understand ma? Similarly, now can you say what is the change in entropy of surroundings ma? Change in entropy of surroundings will be how much, can you say? Change in entropy of system we have written, no? Change in entropy of surroundings, it will be equal to minus Q reversible divided by T. This is the equation. Why I have written minus Q ma? Because surroundings are losing heat energy, no? Surroundings are losing heat energy. When it loses heat energy, what happens to its entropy? Entropy decreases. Okay ma? System is gaining heat energy. If system gains heat energy, what happens to its entropy? Entropy increases. Are you able to understand ma? Oka system ne mere heat chesnaru anukondi. If you start heating a system, what happens to the speed of the molecules in that system? Speed of the molecules increases, no? It means randomness, disorderedness also will increase. So the system, if it is receiving heat energy, its entropy increases. Surroundings is losing heat energy, no? Its entropy decreases. That is why we have written negative symbol here. Are you able to understand ma? So here one more note point you can write down. So ds in the case of irreversible process will be greater than Q in the case of irreversible process divided by time taken. Okay, ma? It means in the case of irreversible process, equation I cannot write here. I have to write a greater than symbol. Okay? So these equations are satisfied in which condition, ma? They are satisfied only in the case of reversible process. Are you able to understand? That's it. So see, ma, Q reversible divided by temperature. If heat energy increases, automatically randomness, velocity of the particles increases. Water ni heat chestunnaru anukondi, water molecules ekku speed tho travel avadam start chestam. Ekku speed tho travel ayina ante meaning emi, vaati disorderedness, randomness పెరిగినాయని అర్థం. Are you able to understand? That's it. Okay. So that is about the equation of entropy. Okay. Come on, make a note up to here. Processes, no? We have studied about isothermal process, adiabatic process, clear, no? Isochoric process, similarly cyclic process, reversible, irreversible, all we have studied. So in all those processes, we will try to understand how this entropy change will take place. Clear, no? Now let us see. So the first process which we are studying is cyclic process. Now can you say what is meant by cyclic process? Cyclic process means what? Can you say? If system is able to return to its initial states, then such process is called what? Such process is called cyclic process. Are you able to understand, ma? So for example, let us see. So this is pressure and this is volume, PV graph. So initially a gas has undergone this type of process. So here what are the initial states? P1 and V1. Okay. And temperature also we will take. So let the temperature be T1. So a process is undergone here and the gas has reached to some final state. At the final state, pressure is P2, volume is V2, temperature is T2. Are you able to understand? Now by you doing some another process, if I am able to return to the original states, then such process is called as cyclic process. Are the cyclic process? So first from P1, V1 to T1, I have reached to P2, V2, T2 by doing some process. By doing some another process, if I am able to return to the original states, it means nothing has changed. No? After this total process, nothing has changed. Okay. So if nothing has changed, then I can say delta S will be 0. Change in entropy will be how much? 0. Because this is what kind of process? Cyclic process. There is no change in entropy. Are you able to understand? So this is the first process. Second process is adiabatic process. Okay. So what is meant by adiabatic process, ma? Adiabatic process is Q is equal to 0. Heat energy cannot enter into the system. Heat energy cannot go out of the system. Such process is called adiabatic process. Already chadukunnam thermodynamics. Clear, no? So adiabatic process means what? Heat energy cannot be exchanged. Heat energy cannot be exchanged. Such process is called as adiabatic process. So therefore Q value is how much? 0. Heat cannot enter into the system. Heat cannot go out of the system also. Are you able to understand? Okay, ma? So therefore what I write? Therefore I will write delta S is equals to Q reversible divided by time. Okay. Q reversible is how much? 0. 0 by time is how much? 0. So therefore there is no change of entropy in the case of cyclic process also. Similarly in the case of adiabatic process also. Are you able to understand? Next process. Next process is isothermal process. Okay. Now from here we should be very careful, ma, how to calculate entropy in the case of isothermal process. Okay. Isothermal means, iso means same. Iso ante iso then akadani kada yo. Iso means same ikkada. Thermal means what? Temperature. So temperature is a constant, no, ma? So I can say temperature is a constant. That is called as isothermal process. Or you can say change in temperature is 0. That is also isothermal process. No? There is no change in temperature. Are you able to understand? Now if I write the first law of thermodynamics, okay ma? First law of thermodynamics according to chemistry, then I have to write delta U is equals to Q plus delta W, no ma? This is the first law of thermodynamics according to chemistry, no? Clear, no? Delta U is equals to Q plus delta W. Now if a temperature is not changing, then I can write delta U will never change. Okay? What is delta U? Change in internal energy. Already we studied in thermodynamics, no? What we have studied? Internal energy depends only on temperature. Temperature పెరిగిందంటే ఏది పెరిగినట్లు? Internal energy పెరిగినట్లు. Temperature is not changing, no? So internal energy also does not change. Are you able to understand, ma? So therefore what I write? As temperature remains constant, okay ma? There is no change. There is no change in what? There is no change in internal energy. So delta U is 0. It means that a change in internal energy is 0. Internal energy 0 అని కదా U. అట్లా అనుకుంటారు మళ్ళీ. Are you able to understand, ma? Internal energy is remaining constant. Change in internal energy is not there. So change in internal energy is 0. Understood, no? Therefore I can write 0 is equals to Q plus W or Q plus delta W. I can write like this, no? So therefore heat supplied is nothing but negative of work done. In which process? In the case of isothermal process. Okay? And in thermodynamics already we have studied what is the amount of work done in the case of isothermal process. Do you remember? Oh no. Okay, nene rasta. So Q is equals to negative of work done in isothermal process is how much, ma? So minus 2.303 nRT log V2 divided by V1. This is the equation. Okay, ma? So minus of minus will become plus. Or you can write minus of minus 2.303 nRT log P1 divided by P2. Like this also you can write. Okay, ma? Because in the case of isothermal process, PV is a constant. It means pressure is inversely proportional to volume. Okay. So V2 by V1 can also be written as P1 by P2 also. So I can write like this also. Are you able to understand? So therefore, now substitute in the equation of entropy, ma? So therefore, what is entropy? So delta S in the case of isothermal process is how much? It is Q reversible divided by temperature. So Q reversible is how much? So minus of minus will become plus, no ma? So 2.303 nRT log V2 divided by V1 divided by temperature. Clear, no? So T and T, if it gets cancelled, so delta S is equal to ds is equals to how much? 2.303 nR log V2 divided by V1, or also you can write 2.303 nR log P1 divided by P2. Clear, no? So this is the equation of change in entropy in which process, ma? In the process of isothermal process. Are you able to understand? Equation of change in entropy in the case of which process? Isothermal process. Understood, no? Next one, fourth one. We will study about isobaric process. Isobaric process. Are you able to understand? What is meant by isobaric process, ma? Pressure is a bar means the unit of measuring pressure. Isobaric means same pressure. Okay. So here I can write pressure is a constant, or I can write delta P is how much? 0. Change in pressure is not there. Okay, ma? So in the case of isobaric process, the amount of heat energy which you supply can be written as NCP delta T. I can write like this. Are you able to understand? In the case of isobaric process, pressure is a constant, no? So specific heat of the gas will be how much? Specific heat of the gas will be Cp, or heating the gas at constant pressure. Okay, ma? What is meant by specific heat? Already we have studied, no, ma? Q divided by N delta T is called as specific heat. The amount of heat energy supplied to rise the temperature of 1 mole of a gas by 1 degree rise in temperature is called as specific heat. We are heating the gas in which process? Isobaric process. So specific heat will be Cp, specific heat at constant pressure. Are you able to understand? So therefore Q can be written as NCP delta T, no? Are you able to understand? Now let us write down. So therefore what I can write? Therefore, okay ma? So ds in the case of isobaric process, how I can write? I can write Q reversible divided by time taken, okay ma? Or you can write NCP dt divided by T. This is how I can write. So I am writing ds, no? So change in temperature also I will write dt. Small change in entropy because of small change in temperature. Are you able to understand? Now integrating on both sides. Integrating on both sides. Are you able to understand, ma? So if I integrate, integration of ds in the case of isobaric process is equals to integration of NCP dt divided by T. This is what I can write. ds is what, ma? Small change in entropy. Integration of ds, total change in entropy. Integration is a process of addition, no? Integration ante mani basically addition, add cheyadam ani. So small change converts into total change. So I can write delta S in the case of isobaric process is equals to, clear ma? So N and Cp, they are constants, no ma? Take them out of integration. So integration of 1 by T dt. Okay. So integration of 1 by T dt is how much? It is a natural logarithm of T, and limits are applied from T1 to T2. So here also I will apply the limits from T1 to T2. So integration means limits of integration also should be there, no? So initial temperature is T1, final temperature is T2. So change in temperature T2 minus T1. Okay ma? So therefore the change in entropy in the case of isobaric process is how much ma? I can write it is NCP log T2 divided by T1. This is how I can write. Okay. First of all I have to substitute upper limit, no? Log T2. Then I have to substitute the lower limit minus log T1. So log T2 minus log T1 will be how much? Log T2 by T1. You know this rule, no ma? So log x minus log y is how much? Log x by y. So by using same rule we have written this. Are you able to understand? Now here I have written Ln. Ln means what? Natural logarithm. Natural logarithm means to the base of e. But if I want to convert this one as base of 10, then what I have to do? If I want to convert this logarithm to the base of 10, then I have to multiply by 2.303. Arthamathundi kada? So therefore change in entropy in the case of isobaric process is how much? 2.303 NCP log T2 divided by T1. This is the equation. So this is the change in entropy in the case of isobaric process. Are you able to understand, ma? Why I have written 2.303 understood, no? Here it is natural logarithm. A natural logarithm means what? Ln can be written as log to the base e. This is how I can write. But I have converted this one to the base of 10, log to the base of 10. Then I have to multiply by 2.303. That's it. Clear, no? Okay. Similarly, the next process is called Isochoric process. Okay, ma? What is meant by Isochoric process? Volume is a constant. So volume of a gas is a constant. It means a change in volume is how much, ma? Change in volume is 0. There is no change in volume. Volume remains a constant. Okay. So when you are heating the gas at a constant volume, the total heat energy which you supply converts into internal energy of the gas. Thermodynamics lo chadukunnam gurtunda? Clear ma? When you are heating the gas at a constant volume, మీరు సప్లై చేసే మొత్తం ఎనర్జీ ఏమవుతుంది? The total energy which you supply converts into internal energy of the gas. Okay. So therefore here I can write Q is equals to NCV delta T. In isobaric process what we have written? Q is equal to NCP delta T, heating the gas at constant pressure. But we are heating the gas at constant volume, no? So instead of Cp, I will write Cv, NCV delta T. Okay? So therefore, again doing the same type of process. Okay? Now, no need of doing once again, no? So here I will write same as, calculation same as isobaric process. What is the final equation I got? Same equation I will write here also. So delta S in the case of isochoric process is how much more? 2.303 N instead of Cp? NCV log to the base 10 T2 divided by T1. That's all. That is my equation of change in entropy in the case of isochoric process. Are you able to understand? Only they process 14 సార్లు రాయడం ఎందుకు మీరే రాసుకోండి. These calculations are not required, just for your understanding. These values you are supposed to remember. Equations you should remember. Understood, Nama? So these are the different equations of entropy in different processes. Okay? So all these equations you must remember very carefully. So in the case of cyclic process, change in entropy is not there, 0. In the case of adiabatic process, change in entropy is not there, again 0. In the case of isothermal process, 2.303 NR log V2 by V1 or P1 by P2. In the case of isobaric process, it is 2.303 NCP log T2 divided by T1. In the case of isochoric process, 2.303 NCV log to the base 10 T2 divided by T1. That's all. These are the equations which you should remember. Are you able to understand? Your pedlu alade. Okay. So in the last class we have studied about different equations for change of entropy, norma. So some more conditions we are studying, like what is the change of entropy in the case of different process in the case of ideal gas. Are you able to understand, no? So first of all, let us take this process now. What is P1 V1? This is called initial state, no? P1 V1 is called as initial state of the gas. Then we are moving to P2 V2, which is called as final state of the gas. So in moving from P1 V1 to P2 V2, what is the change in entropy I want to calculate? Are you able to understand? See, but directly in moving from P1 V1 to P2 V2, instead of moving directly, I can write in steps also, no? Are you able to understand, no? I can write in steps. So what is the first step? I can write P1 V2, I can write like this. Then from here again I will move to P2 V2. Are you able to understand, no? So this is the first process where pressure is remaining constant, no? So here also P1, here also P1. So pressure is remaining a constant. But what about volume? Volume is changing. So can you say this is what kind of process? Pressure is constant, no? So here pressure is a constant. So definitely I can say this is a isobaric process. Are you able to understand? So here change in entropy will be delta S in the case of isobaric process. Clear? Then I am moving from P1 V2 to P2 V2. So in this condition volume is constant, no? Pressure is changing from P1 to P2, but volume is a constant. So this one I can call it as a isochoric process. Are you able to understand, no? This is an isochoric process. So here what is the change of entropy? Delta S in the case of isochoric process. Okay? And change in entropy in isobaric process, change in entropy in isochoric process. Yesterday we have written the equations. So write the same equations here. So total change in entropy is how much? It is equal to change in entropy in the case of isobaric process plus change in entropy in the case of isochoric process. Are you able to understand? So in the case of isobaric process, what is the formula for change in entropy, ma? It is 2.303 isobaric, no? So NCP log to the base 10, so T2 divided by T1. This is the equation. Are you able to understand? This was the equation which we derived yesterday, no? Similarly, what is the change in entropy in the case of isochoric process? Just instead of NCP I have to write NCV, that's all. Therefore 2.303 NCV log to the base 10 T2 divided by T1. This is the equation. This is how I can write. So if any process is given, Manoj tvarga ravali. Okay, clear now? So if this is the process which is happening, then definitely I can write in steps and I can add the total entropy. Are you able to understand, ma? See, my entropy, how I am able to add like this, can you say? I am just adding like 1 plus 2 is 3, no? I am just adding 1 plus 2 is equal to 3, algebraic form. How can I add like this? Because already we have studied that entropy is a state function. Already we studied, no, ma? Entropy is what kind of function, ma? It is a state function. So it depends only on initial position and final position. It doesn't depend upon the path in which we are moving. What are the path functions? Path functions saving. Heat supplied is a path function. Are you able to understand, ma? Work done is a path function, but entropy is a point function. It depends only on initial point function only, no? State function, or you can write just it is a point function. Point function means what? It depends only on initial point and final point. Are you able to understand? So whatever may be the process I will do, change in entropy, definitely I can say the change in entropy in first condition and change in entropy in second condition. Definitely I can write like this. Clear, ma? Similarly, if I write one more example, so let us consider I want to change the gas from T1 V1 to T2 V2. So in this condition, can you calculate the total change in entropy? Calculate cheyandi. Clear, no, ma? So what is T1 V1, ma? Initial state of the gas. Initial temperature is T1, initial volume is V1. And what is the final state of the gas? Final temperature is T2, final volume is V2. Now in this total process, what is the change in entropy? How can I calculate? Again, I can travel in steps, no? How can I travel in steps? So first I travel like this, then I go like this. Are you able to understand, ma? So let us consider this is T1 V2, and finally I am moving from T1 V2 to T2 V2. Okay. Now in traveling from here to here, this is what kind of process, ma? Temperature is constant, no? So here what is constant? Temperature is a constant. Temperature is a constant means this is isothermal process. Okay, ma? Therefore what is the change in entropy? Delta S in the case of isothermal process. Are you able to understand? Now in moving from T1 V2 to T2 V2, this is what kind of process? Volume is remaining constant, no? So this is a isochoric process. Are you able to understand, ma? What is constant here? Volume is a constant. So what is the change in entropy? Delta S in the case of isochoric process. That's all, ma? Therefore what is the total change in entropy? Chapandi, silent guntarema. Total change in entropy is how much? Change in entropy in the case of isothermal process plus change in entropy in the case of isochoric process. That's all, no, ma? And this formula already we have written, no? So what is the change in entropy in the case of isothermal process? 2.303 nr log V2 divided by V1, or you can write P1 divided by P2 also. Are you able to understand? And what is the change in entropy in the case of isochoric process, ma? 2.303 NCV log T2 divided by T1. Okay, that is the total change in entropy. Are you able to understand, ma, how we are doing? So in this method, very easily you can calculate the total change in entropy, whatever may be the state functions are given. Yes, state function aina ila meer cheyachchu. Okay, that's it. Make a note up to here. నువ్వు ప్రతిరోజు 5 నిమిషాలు లేట్గా ఎందుకు వస్తావు చెప్పంటావురా నేను? చెప్తాను, ఊరికి అడిగినాను వద్దన్నా చెప్తా, ఊరికి అడిగినా చెప్పాలా వద్దా? ఎందుకంటే ట్రైన్ పేరు పెట్టుకున్నావు కదా, భారతదేశంలో ట్రైన్లు పొరపాటున కూడా టైంకి రావన్నమాట. ఆ ట్రెండ్ను అలా ఫాలో అవుతా ఉన్నావు. Okay, see. So next application which we are studying is change of entropy in the case of phase changes. What is meant by phase change, ma? Water converting into ice converting into steam. This is called phase change, no? State is changing. State doesn't mean Tamil Nadu, Andhra Pradesh, Karnataka, liquid state to solid state to gaseous state. Are you able to understand? See, ma, when phase is changing, in physics you should have studied, no, in heat topic. When phase changes, what are the changes which happens? Temperature never changes. For example, if you take 1 kg of ice and if you want to melt 1 kg of ice, then you have to supply heat energy, no? 1 kg ice ni melt cheyalante meer heat energy ni supply cheyali. So until total 1 kg of ice converts into water at 0, temperature of water will not increase. Ice మొత్తం మెల్ట్ అయిన తర్వాతే టెంపరేచర్ పెరుగుతుంది. Are you able to understand? So the total heat energy which you supply will be utilized for what? Only changing the phase of that particular material. Are you able to understand ma? Temperature never changes in phase transformations. Phase transformations lo temperature maradu. Are you able to understand? That is why that heat which you supply is called latent heat in physics. Latent heat means what? Hidden heat. మీరు ఐస్ని హీట్ చేస్తూ ఉంటారు, టెంపరేచర్ మాత్రం పెరగదు. ఏమైంది తల కొక్కుంటూ ఉంటారు మీరు. అర్థమవుతుంది కదమ్మా? కంటిన్యూస్లీ యు ఆర్ సప్లయింగ్ హీట్ ఎనర్జీ, బట్ టెంపరేచర్ నెవర్ చేంజెస్ అండ్ యూ కెన్ నెవర్ అండర్స్టాండ్ వాట్ ఈస్ హ్యాపెనింగ్. What is happening? That total heat energy is utilized for changing the phase of the substance from solid state to liquid state and from liquid state to gaseous state. So temperature never changes in phase transformations. And system is always in equilibrium. What is meant by system is in equilibrium? System is in equilibrium means concentration of products and concentration of reactants is a constant. It never changes. Okay ma? For example, if you are heating water, concentration of water, will it change? It never changes. For example, if you are melting ice, concentration of ice, will it change? It never changes. So system is always in equilibrium. So another point is total heat supplied is nothing but a change in enthalpy. Are you able to understand ma? What is meant by enthalpy? Enthalpy is nothing but the total amount of internal energy the system possesses plus the product of pressure and volume. This is called as enthalpy of a system. Are you able to understand ma? This we will discuss later. Now just for your information I am writing here. Are you able to understand? So therefore total heat supplied is nothing but total change in enthalpy. I can write a delta H. So this is always satisfied in the case of phase changes. Are you able to understand ma? And total heat which you supply, it is always utilized for changing the phase only. Temperature never changes. ఈ పాయింట్స్ అన్నీ మీరు గుర్తుపెట్టుకోవాలి ఇన్ ఫేస్ ట్రాన్స్ఫర్మేషన్స్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? టెంపరేచర్ నెవర్ చేంజెస్, టోటల్ హీట్ సప్లైడ్ ఇస్ నథింగ్ బట్ టోటల్ చేంజ్ ఇన్ ఎంథాల్పీ అండ్ ఓన్లీ స్టేట్ చేంజెస్, టెంపరేచర్ డస్ నాట్ చేంజ్. ఓకే, సో ఇన్ ఫేజ్ ట్రాన్స్ఫర్మేషన్స్ ఐ కెన్ స్టడీ అబౌట్ టూ టైప్స్ ఆఫ్ ట్రాన్స్ఫర్మేషన్స్ నమా. సో వన్ ఈస్ entropy of what you call fusion and entropy of vaporization, both we can study. Okay, so first of all we will study entropy of fusion, or you can also call it as melting also. Okay, so what is meant by fusion? Solid converting into liquid, or also you can say liquid converting into solid. This is called as fusion. Are you able to understand? So therefore here how can I write? Delta S in the case of fusion can be written as Q divided by T. Q is heat supplied, no ma? Heat supplied in the case of fusion. So heat supplied in the case of fusion can also be written as change in enthalpy in the case of fusion divided by temperature of melting. So I can write like this. Are you able to understand, ma? So what is the change which we are doing? This is the formula of entropy, no? Q divided by temperature. Instead of Q, what I am writing? Change in enthalpy, that's all. Change in enthalpy divided by which temperature? See, phase transformations always happen at a particular temperature, and that temperature is called as temperature of melting. Are you able to understand? For example, if you take ice, ice starts converting into water at which temperature? Only 0 degrees Celsius. Are you able to understand? 0 దగ్గర మాత్రమే ఐస్ వాటర్గా కన్వర్ట్ అవుతుంది. వేరే టెంపరేచర్ దగ్గర ఎక్కడ కూడాను పాసిబుల్ అవ్వదు. దట్ ఈస్ వై ఆల్రెడీ వీ హ్యావ్ రిటన్ టెంపరేచర్ ఈజ్ ఏ కాన్స్టెంట్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? సిమిలర్లీ ఐ విల్ రైట్ ఎంట్రోపీ ఆఫ్ vaporization, and here temperature of melting, if it is water, you can write 0 degrees Celsius, or in Kelvin you can write 273 Kelvin also. Are you able to understand ma? So you better write that case also. Okay, case is what? If water is taken, then change in entropy in the case of fusion, how can I write ma? So change in enthalpy in the case of fusion divided by 273 Kelvin. So you can write like this also. 0 degree Celsius is also called 273 Kelvin no ma? ఇలా మీరు రాసుకోవచ్చు. అర్థమవుతుంది కదా? Or you can write 0 degree Celsius is how much? 273 Kelvin. You can write like this. Okay ma? Next, what is the next phase transformation which is possible ma? So here I can say what ice is converting into water. Then if you start heating water, now water at 100, It converts into steam at 100, no? 100 అంటే 100 km/h అని కాదు, 100 degrees Celsius. Are you able to understand, ma? So second application is change in entropy. In which condition? In vaporization. Are you able to understand? So therefore again similarly how can you write? So first of all, what is meant by vaporization, ma? Liquid form it converts into steam or vapor form, or steam converts into liquid. Both of them you can call them as change in entropy in the case of vaporization. Are you able to understand, ma? For example, water converting into steam, steam condensing into water. Both are taking place at a constant temperature of 100 degrees Celsius. Are you able to understand? Therefore again similarly how can you write, ma? Delta S vaporization is equals to Q vaporization, heat energy supplied in vaporization, divided by temperature of boiling. That temperature is called boiling temperature only, no? What is meant by boiling temperature? Temperature at which liquid converts into gas. That is called as boiling temperature. Are you able to understand? So again I can write change in enthalpy in the case of vaporization divided by temperature of boiling. Okay, ma? And case you can write. Case is what? If water is taken. Okay, ma? If water is taken. If you take water, then what is the temperature of boiling, ma? Temperature of boiling 100 degrees Celsius. In Kelvin you can write 373 Kelvin. So substitute those values. So delta S in the case of vaporization is how much you can write? Delta H of vaporization divided by 373 Kelvin. So you can write like this also. Are you able to understand? ఏమీ లేదు ఇక్కడ విషయం, శూన్యం అంతా. జస్ట్ కండిషన్స్ కేసెస్ రాసుకుంటూ పోతాను, దరిద్రం అంటే దాంట్లోంచే క్వశ్చన్లు వస్తాయి, అంతకు మించి ఏం లేదు. క్లియర్, మా? దట్స్ ఇట్. ఓకే, దెన్ వీ స్టడీ. Okay, for example, if I write one more application, ma, third one, entropy in or change in entropy in sublimation. Change in entropy in the case of sublimation. Now can you say what is meant by sublimation, ma? Sublimation means what? Solid directly converting into gas bypassing the liquid phase. For example, you know camphor. క్యాంఫర్ తెలుసు కదా, తెలుగులో ఏమంటారు దాన్ని? కర్పూరం. సో ఇఫ్ యూ ప్లేస్ ఇట్ ఇన్ ఎయిర్, ఇట్ డజంట్ కన్వర్ట్ ఇంటూ లిక్విడ్ ఫామ్, డైరెక్ట్లీ ఇట్ కన్వర్ట్స్ ఇంటూ వేపర్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో దట్ ఈస్ కాల్డ్ యాజ్ సబ్లిమేషన్. సో దేర్ ఫోర్ హౌ ఐ కెన్ రైట్ సాలిడ్ డైరెక్ట్లీ కన్వర్టింగ్ ఇంటూ వేపర్, ఆర్ వేపర్ కండెన్సింగ్ డైరెక్ట్లీ ఇంటూ solid. That is called as sublimation. Are you able to understand, ma? So here I can write delta S in the case of sublimation is equals to Q of sublimation divided by temperature of sublimation. Reversible. So solid vapor loki marochu, vapor direct ga solid lo kuda condense avvachu. Are you able to understand, ma? So therefore this how I can write delta H sublimation divided by temperature of sublimation. Okay, ma? And entropy is a which function? Entropy is a point function. Entropy is a point function, no, ma? It is not a it is not a path function. It depends only on initial point and final point. కాబట్టి మీరేం చేయొచ్చు చెప్పండి. So delta S sublimation can also be written as delta S of fusion plus delta S of vaporization. So you can write like this also. Are you able to understand? So for solid directly converting into vapor, we can consider it converts into liquid form also, no? Okay, so solid converting into liquid, delta S fusion. Liquid converting into gas, delta S vaporization. Are you able to understand, ma? If you add both of them, definitely you will get this value also. Because endukala, because entropy is a point function. It only depends on initial point and final point. It doesn't depend on the path taken. ఎలా ట్రావెల్ చేస్తున్నాము దానిపైన అది డిపెండ్ అవ్వదు. డిస్టెన్స్ డిస్ప్లేస్మెంట్ లాగా అనుకోండి, డిస్టెన్స్ పాత్ పైన డిపెండ్ అవుతుంది, డిస్ప్లేస్మెంట్ అదంతా పని లేదు, ఎక్కడ పోయినా చెప్పంటుంది అనమాట అలా. సో మేక్ నోట్ ఆఫ్ దిస్. ఓకే, సో నెక్స్ట్ we are studying about the change in entropy in the case of universe. So what is meant by universe already we have studied, Nama. The system which we are studying plus the surroundings in which system is not present, that is called as surroundings. So system plus surroundings will give universe. Are you able to understand? So therefore total change in entropy in the case of universe is equals to change in entropy in the case of system plus change in entropy in the case of surroundings. Are you able to understand, ma? Now see. So change in entropy in the case of universe I can study in these many processes now. First of all I will study reversible process, then I will study irreversible process. And reversible process can be cyclic also, non-cyclic also. Are you able to understand? Similarly, irreversible process also, it can be cyclic also, it can be non-cyclic also. Okay. So first of all, let us draw some conclusions before filling this table. See now. In the case of cyclic process, change in entropy of the system is always zero, whether it is reversible process or whether it is irreversible process. Are you able to understand, ma? If it is a cyclic process, cyclic process means what? Already we discussed, So first of all we travel by one process, and by second process again I reach to the same state. That is called a cyclic process. Are you able to understand? Sima. So first of all I travel from here to here. It may be adiabatic, it may be isothermal, it may be isochoric, it may be anything. Are you able to understand? So then by doing another process, again if I am able to reach to the same state, then it is called a cyclic process. So state functions change button ledhu kada. State functions are not changing. If a state functions are not changing, entropy also doesn't change. Are you able to understand, ma? So entropy of the system, change in entropy of the system is zero. In which process? In cyclic process. This is one point which already I discussed in the last class. Are you able to understand, ma? Similarly, if it is irreversible process, if it is irreversible process, are you able to understand? Then I can say that, so delta S or ds of the system is greater than 0, okay ma? And it is non-cyclic irreversible process. So ds of the system is greater than 0. Similarly, ds of the surroundings also not greater than 0, greater than Q irreversible divided by temperature, and this is also greater than Q irreversible divided by temperature. This point also I have explained you yesterday only, no? If it is an irreversible and which process? Non-cyclic process. Okay, ma? And this is satisfied for both reversible and irreversible. Are you able to understand, ma? For whatever it may, whether it is reversible or irreversible, so change in entropy of the system will be 0. Are you able to understand? System lo entropy change undadu eppudu adi cyclic process ainappudu, because always we are reaching to the same position, no? Are you able to understand, ma? Now if it is irreversible and non-cyclic process, then change in entropy of the system is always greater than Q reversible divided by temperature, and temperature or change in entropy of the surroundings, again it is greater than Q irreversible divided by temperature. These points you should remember. Okay. Once you remember them, now let us try to fill this table. So which is the first one we are studying, ma? Reversible cyclic process. Clear, no? So because this is a cyclic process, ds of the system is how much? 0. That's what I have written, no? Change in entropy of the system is 0. And this is a reversible cyclic process. So ds of the surroundings is also how much? ds of the surroundings is also 0. Okay. Then what is the total change in entropy of the universe? So it is ds of a system plus ds of surrounding. Write it very, very clearly, ma. So total it will be 0. Are you able to understand? So what do you understand here? We understand that in reversible cyclic process, there is no change in entropy in the case of universe. Are you able to understand? But the problem is, so where shall I write? Here I will write down now. In notes you write here, but in this board I am writing here. This reversible cyclic process practically not possible. It is not practically possible. This is a theoretical process. Are you able to understand, ma? So we say that efficiency of a mission can be made 100%. Efficiency of a mission can never be 100%. Always there is some loss of energy, because energy always converts into heat energy. No? 100% energy you can never convert into work. Are you able to understand? Similarly, reversible cyclic process where these conditions are met, that is never possible. Are you able to understand? Because according to second law of thermodynamics, after any process, entropy of a system or entropy of universe always increases. That we will study later. Okay? So next item. See, non-cyclic reversible process. So this is a reversible process, but this is what kind of process? Non-cyclic process. Are you able to understand? No. So consider this is a system, okay, in which gas is present, and temperature of the gas is T1. Or I will write here. Temperature of the gas is how much, ma? Temperature of the gas is T1. And this is the surroundings. Okay? And surroundings temperature is T2. So let us consider T2 is greater than T1. Temperature of surroundings is greater than temperature of system. Then what will happen? Then heat energy travels from surroundings to temperature. This is what happens, no? And this is what kind of temperature? This is heat energy supplied in reversible process. Reversible process. This is reversible process only, no? So here heat energy is entering into the system. So this is a non-cyclic process. Non-cyclic process means delta S of the system is not zero. Is not zero. Only in cyclic process only it is zero. Non-cyclic process it is not zero, because it is not able to reach the original state, no? Non-cyclic process means what? So this is one process, this is another process. So initial states, final states, they are not same. Are you able to understand, ma? So therefore I can write change in entropy in the case of system. System means this one is how much? It is heat received in the case of reversible process divided by temperature of the system. Are you able to understand? Change in entropy, what is the formula? Q by T. Q in which process? Reversible process. Temperature of what? Temperature of the system. Satisfied now? Okay. These exceptions gurtupettukovali. Then very easily we can fill the table, and whether question is given on this table, very easily you can answer. Are you able to understand, ma? Similarly, delta S or ds of surroundings is how much, ma? It is losing heat energy, no? So minus Q reversible divided by T2. Temperature of the surroundings is T2. Are you able to understand, ma? Okay. Now see, ma. Now when you observe ds of system and ds of surroundings, which one is bigger? Magnitude wise, which one is bigger? ds of system is bigger. How can you say? Don't check for positive or negative values. Magnitude wise, already cheppinanu kada. Magnitude wise, out of change in entropy of system and change in entropy of surroundings, which one is bigger? System. How can you say? Huh? Magnitude aduguta unnaru. Magnitude. I am not asking entropy of which system is increasing, which entropy of which system is decreasing. I am not asking about that. I am asking about, you remove plus symbol and minus symbol. ఈ ప్లస్లు మైనస్లు తీసేయండి కాసేపు, ఇది ఇలా వదిలేసి. So ds of system is greater or ds of surroundings is greater? System. How can you say? That is the point which you should understand here. Okay, ma? See, ma, numerator is same, no? So surroundings anta temperature lose ayindho, system ante heat energy ni gain chesukundi. Heat energy ni gain chesukundi. So numerator is same. But T2 is greater than T1, no, ma? Okay? And temperature it is in denominator. Temperature ekkada undi? Denominator. If denominator is smaller, total value will be bigger. Ante kada? 10th taragati pass ayinaru kada. Mari cheppandi mari. Clear, ma? So 10 by 2 is bigger, 10 by 5 is bigger.
10 by 5. 10 by 5.
10 by 2 is 5. 10 by 5 is 2 only, no? So definitely this one is bigger. Why this is bigger? Because denominator is smaller. Understood, no? So here T1 is smaller, no? T1 is smaller. So ds of the system is bigger. But this is positive value and this is a negative value. Are you able to understand? So therefore I can say that, here I am writing the reasoning I will write here, ma. As T1 is smaller than T2, okay, ma, magnitude of ds of system is greater than magnitude of ds of surroundings. Okay. So entropy has changed by greater value of which one? System or surroundings? ds of system is greater, no, ma? So change in entropy in system is greater when compared to change in entropy of surroundings. అర్థమైంది కదా? ఇటువంటి వాటిపైన కెమిస్ట్రీలో క్వశ్చన్స్ అడిగేది. ఆర్ ఏబుల్ టు అండర్స్టాండ్? ఓకే. సో దేర్ ఫర్ నౌ ఇఫ్ ఐ రైట్ ds of universe, ds of universe, it is ds of system plus ds of surroundings. Okay, ma? One value is positive, another value is negative. Positive value is bigger or negative value is bigger?
Positive.
Positive. ఈ వాల్యూ పెద్దగా ఉంది కదా, సో టోటల్ వాల్యూ ఆల్సో విల్ బి పాజిటివ్. ఫర్ ఎగ్జాంపుల్ ఐ కెన్ సే, this is plus 10, this is minus 8. 10 is bigger, 8 is bigger. 10 is bigger. So 10 minus 8 plus 2. Are you able to understand, ma? So here also I will get ds of the universe is positive. Clear? ds of the universe is positive means what? Positive అంటే ఏమంటారా? లాస్ట్ క్లాస్లో చదువుకున్నాం కదా. ds is positive means entropy is increasing. Are you able to understand, ma? So therefore in reversible non-cyclic process, so entropy of the universe finally increases. ఇది conclusion. ఈ conclusion చేయడానికి ఈ సుత్తంతా చేస్తున్నాము. Are you able to understand, ma? So here what we write, finally entropy of system, entropy of universe increases. ఆరో సింబల్ పెట్టారంటే ఎంట్రోపీ ఆకాశానికి పోయిందని కాదు, అయ్యో పెరిగిందనేది. మీ తెలివితేటలు కొంచెం ఆలోచించండి. క్లియర్, మా? ఫైనలీ వీ హ్యావ్ అబ్జర్వ్డ్ దట్ ఎంట్రోపీ ఆఫ్ ద యూనివర్స్ హ్యాస్ increased. That is the observation. Okay. Now let us come to irreversible cyclic process. Are you able to understand, ma? Now see. So questions can be asked on any of these parameters, ma. దేనిపైనైనా మీ క్వశ్చన్ అడగచ్చు. కేర్ఫుల్గా విని కేర్ఫుల్గా బట్టి కొట్టండి. అర్థం చేసుకునేది ఏం లేదు, బట్టి కొట్టడమే అంతే. క్లియర్, మా? సో cyclic process. Clear? Now see. So cyclic means what I have written? Cyclic means what I have written, ma? Delta S of the system? Zero. So write down that one. So ds of the system is 0. Are you able to understand? But surroundings is not 0.
Minus q reversible by T.
Here you need not write minus. So ds of surrounding is greater than q in the case of irreversible process divided by temperature. Are you able to understand, ma? So here ds of the universe, this is positive. Are you able to understand, ma? So this is positive value, this is also a positive value. If you add both of them, then also it will be positive. It means after irreversible cyclic process, again entropy increases. Are you able to understand? Here also entropy increased, here also entropy of the universe has increased. Clear, no? Entropy of the system is 0. Entropy of the surroundings is not 0. It is always greater than q irreversible divided by temperature of the surroundings. Understood, no, ma? Next, coming to non-cyclic process. Are you able to understand? So this is non-cyclic process, no, ma? ds of the system is not 0. ds of the system is not 0. So therefore what I can write? So ds of system is greater than q irreversible divided by T1. Understood, Nama? Similarly, ds of surroundings is equals to or greater than Q irreversible divided by T2. Are you able to understand? And again here, if you write a negative value here, are you able to understand? Again positive value is greater than negative value. So again entropy of the universe increases. It becomes positive. Okay. So again I can write ds of universe is how much? It is positive value. Increases. Total entropy of the universe increases. So if you see all the processes, in every process, entropy of the universe has finally increased. But this case is an exception. Here entropy of the universe is 0. Abu, time हो गया ना? 7 कुछ ना भेज. Okay. So are you able to understand, ma? So finally what we understand, Sima, here, so change in entropy in the case of universe is how much, ma? It is 0. But what we have written, this is practically not possible. This case is not possible. Are you able to understand? This is possible, this is possible, this is possible, that is also possible. So in all these cases, what about the change of entropy in the case of universe? It has increased finally. And this is exactly what is called as second law of thermodynamics. This observation name antam manamu second law of thermodynamics. So what is the statement of second law of thermodynamics, ma? Run. So unda akkada benchu kuchu 7k class 7:45 వచ్చారే మీరు. ఏ సార్? అట్లానా? ఓకే ఓకే ఓకే. సో అండర్స్టూడ్ నమ్మా? సో రైట్ ఆన్ ద స్టేట్మెంట్. ఇది రన్ అయితేనే ఉందా? ఓకే అమ్మా. సో వాట్ వాస్ అవర్ ఫైనల్ అబ్జర్వేషన్? అవర్ ఫైనల్ అబ్జర్వేషన్ వాస్ దట్, so after any process, whether it is reversible or irreversible process, finally entropy of the universe has finally increased. This is exactly what is called as second law of thermodynamics. So how can we write the statement? Well, statement wise I can write, after any process, clear ma? Entropy of universe finally increases. Are you able to understand, ma? So this is called as second law of thermodynamics according to physics. Okay ma? Sorry, chemistry. Physics prakaram inko definition undi. Okay? Physics prakaram definition emi, efficiency of the system can never be 100%. Adi physics prakaram definition. Idi chemistry prakaram entropy peragali. Idi anlo unda? Okay. So because we have written second law of thermodynamics, we will write third law also, ma? So third law of thermodynamics. Are you able to understand? So it says that at 0 degrees we should not write, 0 Kelvin, the change in entropy for a perfect crystalline substance, మాట్లాడితే పైనుంచి కిందికి వేస్తా, సెకండ్ ఫ్లోర్ నుంచి. ఓకేమా? ఎంట్రోపీ ఫర్ ఎ పర్ఫెక్ట్ క్రిస్టలైన్ సబ్స్టెన్స్ ఈజ్ 0. ఓకేమా? దిస్ ఈస్ కాల్డ్ యాజ్ ద థర్డ్ లా ఆఫ్ థర్మోడైనమిక్స్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? అట్ విత్ టెంపరేచర్? అట్ ఎ టెంపరేచర్ ఆఫ్ 0 కెల్విన్. 0 కెల్విన్ అంటే -273.15 degree Celsius. So this is the least possible which is present in the universe, no? So less than this temperature it is not possible. Intakana least temperature manaku srustilo ledannamata. Okay? So there is no limit for higher temperature. Higher temperature ki limit ledu. But God has created a lower limit for lower temperature, and it is -273.15. So at this temperature, the total change in entropy for which kind of crystal, for which kind of substance? Perfect crystalline substance is always 0. So this is called as the third law of thermodynamics. Understood, Nama? Okay. Then one more important point we will write here, ma. One more important point is, so change in entropy in a chemical reaction. Okay, ma? Change in entropy in the case of a chemical reaction. Are you able to understand? So here I can write the change in entropy in a chemical reaction is equals to the change in entropy in the case of products minus change in entropy in the case of reactants. Okay. So I think in Neet 2017 or 18 question was asked directly on this relation. Clear? So what is the total change of entropy in the case of reaction? Change in entropy in the case of products minus change in entropy in the case of reactants. Are you able to understand, ma? And you write one more note point, ma. Note point is that change of entropy is always calculated per mole only. Okay, ma? Change of entropy we calculate for what? We calculate only for 1 mole of a substance only. ఒక atomకు ఒక moleculeకు define చేయం. Are you able to understand, ma? Any calculation in chemistry, not only entropy. Almost every calculation in chemistry we always do only for the case of a single mole. Okay? And what is meant by mole? Mole అంటే చెప్పడం వరకు బాగానే ఉంది సార్. క్వశ్చన్లు అడగాకండి మమ్మల్ని. క్వశ్చన్లు అడిగితే మాత్రం చెప్పలేము మేము. అంత లెంత్ కాకుండా కొంచెం షార్ట్గా చెప్పరా. 1 mole is just the total number of 6.022 into 10 power 23 molecules or atoms or ions. This is called as 1 mole. Are you able to understand, ma? Mole అంటే నంబరే కదా, ఇంకేం లేదు. Mole is what? Mole is a number. బోల్దాలి, వెరీ గుడ్. So 6.022 into 10 power 23 atoms or molecules or ions, this is called as a mole. So we always define energy, entropy, enthalpy, Gibbs energy, everything we calculate only for 1 mole only in the case of chemistry. Are you able to understand? ఒక atomకు ఒక moleculeకు define చేయాలి. Clear? That's it. Sima, see this question. Questions on change in entropy. Sima. So he is asking what is the entropy change in the fusion of 1 mole of a solid melting at 27 degrees Celsius is dash. These are the options. And the latent heat of fusion is already given. Are you able to understand? So first of all, let us see what is meant by change in entropy in the case of fusion, ma. So change in entropy in the case of fusion. Fusion means what? Fusion means solid converting into liquid. Clear, ma? Or liquid converting into solid. This is called as fusion. So it means question is based on what? Question is based on change of entropy in the case of phase transformations. ఇక్కడ phases కదా change అవుతున్నది. Solid state it is converting into liquid state. So question is based on phase transformations. Are you able to understand, ma? So in phase transformation, whatever heat energy you supply, మీరు సప్లై చేసే టోటల్ హీట్ ఎనర్జీ ఏమవుతుంది? It is utilized for changing the phase only. That's what we have studied, no? In phase transformations, what happens? Whatever energy you supply, that will be converted to change the phase of the system only. Temperature of the system does not rise. Are you able to understand, ma? Okay. Next, let us. Latent heat of fusion means what? Latent heat means, already we studied, no? Latent means hidden heat. It means to melt 1 mole of this particular material, how many joules is required? 2930 joules of heat energy is required. Adi dani artham. Arthamavutundi kada ma? So latent heat means it is written as Q, the amount of heat energy you supply. Okay? Or you can write in small letters. Okay? This is how much? 2930 joules per mole. What is the meaning of this one? It means to melt 1 mole of this substance, ఒక మోల్ సబ్స్టెన్స్ను మెల్ట్ చేయడానికి ఎంత ఎనర్జీ కావాలి మనకు? వి రిక్వైర్ 2930 joules of energy. That is the meaning of latent heat. Are you able to understand, ma? Now directly apply the formula, which is the formula here. Delta S in the case of fusion is equals to, so Q in the case of reversible process divided by temperature of melting. Are you able to understand, ma? Q reversible is nothing but a change in enthalpy. Already we have studied, no? In the case of fusion divided by temperature of melting. Okay, ma? Change in enthalpy. In this condition, what is a change in enthalpy? Total heat energy supplied. Because the total heat energy you supply, it will not do any work. Adi work cheyadu. It totally is converted into changing the phase of the system. So here change in enthalpy is nothing but heat energy supplied. Already we discussed, no? అందుకే అన్ని పాయింట్స్ రాస్తున్నాను నేను. పాయింట్స్ ఊరిగా పనిలేక రాయలేదు, అప్లై చేయాలని. అర్థమవుతుంది కదా? సో రైట్ డౌన్. సో డెల్టా ఎస్ ఆఫ్ ఫ్యూజన్ is equals to, what is the heat energy supplied, ma? So 2930 divided by, what is the temperature given? 27, but it is in Celsius, no? Convert this one into Kelvin. So 273 plus 27. So 2930 divided by 300. Okay. Now once you do this calculation, value I am getting in terms of joules only. Because here heat is given in terms of joules only, no? And you have to check the units. Units also given in joules only, no? Joules are kilojoules, and check just call first. Kilojoules lo ivvaladu kada, joules lo ne ichchadu. So you need not convert this one. Directly you can write the answer. So this is approximately 3000 by 300, no? 10 రావాలి. 10 కన్నా కొంచెం తక్కువ రావాలి. 10 కన్నా కొంచెం తక్కువ ఉన్నది ఏది? అది. That is my answer. Okay, ma? So therefore 9.77 joules Kelvin inverse mole inverse. Are you able to understand, ma? So this is the unit of measuring change in enthalpy, ma. Change in enthalpy ki idi unit. Enthalpy gani, change in enthalpy gani idi unit. Okay. See, ma, in the formula what we have, only heat energy per temperature. Okay. So what should be the unit en ravali? Joules per Kelvin. But again mole inverse is also there, no? Ante em arthamaindi meeku? Every calculation we do only for 1 mole only. Adi మీరు అర్థం చేసుకోవాలి. Okay, ma? That's it. So we will continue tomorrow, ma.